Hi, in this video I'm going to be introducing the concept of synthetic division and trying to just kind of familiarize you with when you should use it and how to use it, the basic process. Really, synthetic division and long division, which we just got done with, they accomplish the same task, which is we need to be able to divide polynomials. But we only want to use synthetic division in some cases, and I kind of hit on this in the long division stuff, so I'll just repeat it here. We only want to divide synthetically whenever we're dividing by something easy, which is just x plus or minus a number. So I have 6 problems here, and not all of them are long division problems, and not all of them are synthetic division problems. Remember, long division can be used all the time. Synthetic division really only useful in some situations. And so what I want to do is, I don't really care what I have on top of the fraction, what I'm dividing, the numerator. What I care about is what I'm dividing by. And so I look at this, and I would say, you know what, that's just x plus or minus a number. This would be a good synthetic division problem. Okay, because you're dividing by x minus 1. This, not so easy. It's x squared plus x. That's a little bit more complicated, so this is really a long division problem. Down here, 2x minus 3. I know that kind of looks pretty easy, but because of this 2 here, that makes that a long division problem. We really don't want to do synthetic division here. It's going to make it too complicated. So this is long division. And I see here, that's definitely complicated, right? But here I have x plus a 4. That'd be a good one. I'm dividing by x minus 5. This would be a good one. So in your own words, I hope you can summarize when you use synthetic division. It's really when it's just x plus or minus a number. Not 2x, not x squared, not anything like that. We just want something simple. Okay? The process is going to look like this. So here's a typical problem. Ready? I want to divide x cubed plus 5x squared minus 7x plus 2 by x minus 2. The long division way says that you would go like this. X cubed, and then the squares, and then the negative 7x, and the plus 2 would go inside the long division sign, and then you would have x minus 2 on the outside, right? So I could always do long division, and if you're comfortable with that, then hey, whatever. Okay, but here's a shortcut. Ready? We're going to draw a little box. It's going to look like this. So you can see we have a vertical line and a horizontal line, right? We draw a box, okay? The top row inside the box represents the coefficients of all these powers. So in other words, look at this. I have 1x cubed, I have 5x squareds, I have negative 7x's, and I have a 2 for the constant. Notice every power, just like in long division, every power of x has to be represented. Okay, so if I ever skip over a power, if I'm ever, if I don't have an x here, if it's just, let's say it's just this, without the 7x, I'm trying to cover that up, okay, then you would have to have 1, 5, 0, 2. Okay, every power represented. So that's what we have so far. The number on the outside, this is important, ready? We always assume that we are subtracting something, okay? The question is, what are we subtracting? The value of k goes here from this statement, okay? What are we subtracting? We are subtracting a 2. Therefore, a positive 2 goes here. Other ways that you can remember this same piece of information, okay? If I do an x minus 2, you could just think of it this way. Flip the sign. Okay? Flip the sign and put it there. Make it a positive 2. So in other words, if I'm trying to figure out what goes in this little spot here, if I'm dividing by x minus 1, I would put a positive 1. If I'm dividing by x plus 4, a negative 4 would go in that little spot. If I'm dividing by x minus 5, a positive 5 would go in this spot. So I'm always going to do the opposite sign. Or another way I like to think about it is, what value would you have to put in to make this little chunk of information a 0? X minus 2, I'd have to put in a positive 2 for x to get 2 minus 2. Here I'd have to put in a positive 5 to get 5 minus 5. Here I'd put in a negative 4 to get negative 4 plus 4. So a lot of different ways to think about it. Really, you just need to find one that works for you. If we're only doing x plus or minus a number, the flip the sign thing works pretty slick. Now, ready? We're going to go in a zigzag pattern. Okay, so this is a finished problem. First things first. So I've got the 1, the 5, the negative 7, and the 2. Nothing else exists so far. Okay, this is a finished example we're looking at. I'm going to move downward first, and I'm going to add when I move down. So I get 1, and I have nothing here. Gives me a 1. Then I'm going to go up diagonally. Okay? And when I move up in diagonal, I multiply by k. Remember, k is this value out here. So in other words, what I'm doing here is I'm going to say I got 1 multiply times 2. 1 times 2 is 2. That's the value that goes here. Then I'm going to zigzag down. Okay, it's a sawtooth pattern. Okay, it's going to look like this whenever we get done. Okay, there's your pattern. Down, up and over, down, up and over, down, up and over, like a sawtooth. Okay. 5 plus 2 is 7. 7 times 2 is 14. Add these two numbers. 14 minus 7 is 7. 7 times 2 is 14. 2 times 4 is 16. And I'm done. And what this does then for me is this. The last number here is always the remainder, and everything else is the coefficients, the numbers that go in front of the quotient. In front of the quotient is the answer. Okay? This tells me this. If I did this long division, I would end up with the same answer. If these are x cubes, then these are my x squareds. I'm going down by 1 power. If these are my x squareds, then these are my x's. If these are my x's, then these are my constants. And this is the remainder. Meaning that this, my answer is a single x squared, 7x, 7 for the constant, 16 for the remainder. And the remainder, if you go back to the problems dealing with long division, you know is 16 over what I'm dividing by, which in this case is the x minus 2. Now, next video, what I'm going to do then is I'm going to show you this. We're going to work out these two examples. I'm going to split that into two problems because this one I'm going to work both the long division and synthetic division way so you can compare the methods and see how you get the same answer. Okay? This, all I wanted to do is kind of show you the setup and the process of the sawtooth thing. So you're probably still a little bit confused now, and that's okay. When you see the examples, it's going to make a heck of a lot more sense.